this is the company as we see it. We produce storage components, as I said, from high-speed PCI, NVMe versus SAS arrays, performance hard drive, capacity hard drives to elastic storage or cold storage, as some people call it. And that's what I'm talking about today. When you look at storage, traditionally, it's optimized for so it's the HDST Active Archive SA7000. That's what it looks like. It is designed to give you quick access to your data, even though it is an archive. Data is kept available for you. We want to help you reduce your storage cost, which is a big cost item in big data specifically. We want to help you scale with your demand, and we want to protect your data. And how we do that, I'm addressing in the following foils. So one big aspect of storage is power consumption, because typically machines run 24/7. So we had a strong focus on that with our helium-filled hard drives. The other one is rental space. So we packed data as close as we could, up to 4.7 petabytes in a single 19-inch rack, 42U. And that's about 5 times as dense as you see in the market today. With that, we give you lowest cost per terabyte, and I have some benchmarks there, and overall best total cost of ownership. It's a block storage device. Traditionally, you would access storage as block address, so directly attached drives are addressed block by block, where you give an address and you ask for a certain number of blocks containing data, or you write a certain number. A bit more elaborate or evolved is file-based storage, so a NAS would fall into that category, where you address data by path names, basically. You give it a drive and path, and you access for the file, and there's a number of file systems that you would do that with. Object storage is different in that the protocol is a different one. It can be HTTP, it can be Swift. In our case, it's actually S3. So whoever archives on Amazon today will already know this protocol. And the nicest thing about object storage actually is that it scales much better than other systems, and you can enhance objects with metadata, because with file-based storage you can give file name, file type, owner, creation date, and it basically stops there. With object storage, that becomes unlimited, and you can give it metadata over metadata, so it's much easier to get back to your data via the metadata, and you don't have to remember path name or even block addresses. So why? It's unlimited by path length or availability of logical unit numbers, so it can grow without limits. There's support for rich metadata tags that help you get back to your data. We can give you universal access via the internet or other forms of networking. We enable metadata searches for you. We support very large objects. In the first implementation, actually 16 terabytes per object, which can be a video, which typically is much smaller, or it can be just a whole client that you back up to the archive to retrieve years later. Universities actually use that quite a lot, because if students leave, they have created a whole lot of data and personal files. They just get packed and put in the archive, and when they come back for the PhD, you would find the whole thing on the archive for retrieval to the client. And it will scale definitely to trillions of objects, which you can't have in a SAN or in a NAS. Now, I talked about the capacity. It's 4.7 petabytes, which is quite a lot of data. And typical error rates are 10 to the minus 15. On the other hand, a petabyte is 10 to the power of 15 in terms of bytes. So the presence of an error is actually quite probable at an appliance that size. So we do something for you we call bit spread. First, we encode the data with something called erasure coding, where we chop it into multiple pieces and then put an error correction code over these pieces. And in the code we're using, you can lose up to 5 drives out of drives that are describing a particular object, and your data is still around. So it's much more reliable than RAID, and much more efficient than replication, because if you replicate twice, some people do 3 or 4 replications, your net efficiency of the storage you paid for is only 50%. If you use erasure coding, with all the reliability that I talked about, 5 drives you can lose without losing any data. The efficiency there is actually 72%, so you get much more out of your investment. And the other thing we do, we call bit dynamics, because given that hardware has failure rates, given the size of amount of data on the appliance, actually the presence of an error is quite probable. So we continuously check in the background for the integrity of the data on the archive. If we find bit errors up to the size of 1,000 bits in sequence, we can correct that on the drives. If it goes beyond that, knowing that one drive is affected while there are 17 more responsible for the object, we can actually recreate the missing data before it has any negative effect on you. I'm using the wrong key here. So if you have an installation of multiple systems, the software is set up in a way that every object it does receive, it spreads out as far as it can within the existing installation. So one object would never reside on one drive or one box. It looks for the maximum distribution across the hardware, and that's how we get to this high resilience with no single point of failures. And the other thing that is much nicer than it could be with a RAID system is if a single drive fails, we don't rebuild it as you would have to do on a RAID, which creates high workloads and leads to consecutive errors. When we rebuild data, we just look for which drive failed, which objects are affected by this drive, and recreate the missing bits on other drives in the system. So instead of jumping to 100%, the workload here only increases by 0.17% on average. So there are no hotspots and no consecutive errors as a result. You can create a single namespace under which you keep all your data and start with just one machine. It will provide you with 6 10 gigabit links that you can talk to your data through. And you can add further machines. And the nice thing is it scales. So if a single machine does 3.5 gigabits per second, with 2 you get 7 gigabytes per second, because the interconnect between the machines where we share the fragments of the objects is actually independent of the host side links. So we got 40 gigabits dedicated links between the machines. And you can scale as the data grows without adding anything, right? There's no changes in software, no additional things needed. You just put more boxes and connect them. You can also span geographies by that. We use something called GeoSpread, where the machines in one data center communicate with machines in other data centers. And just like before, the algorithm spreads the data as far as it can. And with a slight change in the format, now going to Erasure code 18/6, we can allow for up to 6 drives responsible for a single object to fail and still have full access to 100% of the data. And if you have 3 data centers with this code, you can actually use a whole data center because it won't contain more than 6 object fragments and still have full access to the data via the 2 remaining data centers. Now, not everybody speaks S3. So if you work with NFS today, if you work with CIFS today, you actually need a gateway to talk S3 on the other end of the gateway. There's so-called centralized gateways where you have one gateway per machine that does that translation to S3 for you. But there are other implementations where you have decentralized gateways, where you basically have NAS-based gateways in your branch office or in your office in a larger complex. And they have local copies of the data. So you have high-speed access as you're used to from a NAS. And in the background, data is replicating to the active archive. And there are 2 implementations of that. One where 100% of the data sits here and is only archived or backed up to the end. But there's another implementation where you have a software, a middleware running here that looks how frequently certain files are accessed. And the not so frequently accessed parts are pushed to the archive. And you just leave a marker on the NAS that there once was this file. And if an access comes around 3 months after the location, the data is pulled back from the archive and made available on the NAS once again. And finally, the so-called software gateways. Most of you, if you do have a Dropbox or an own cloud account, you're already used to that. You have a client with local data, be it images, be it something else, and you just back it up to some kind of archive. So you go through the internet, you go through a firewall, and you do the translation to S3 if it hasn't happened yet, but actually many of these clients talk natively S3. These are the technical bits. So as I said, it's one rack, 42U, 4.7 petabytes, spread across 588 of our helium drives, which combined consume, I know this is a big number, but if you're in big data, you know that that's actually not a lot for this type of capacity up there. The scalability, as I said, trillions of objects up to 16 terabytes in size. In object storage, you don't create partitions, you actually create buckets. So you can create up to 5 million buckets with individual access rights on the machine. Combined throughput, 3.5 gigabytes per second, which is quite fast given that this is not primary storage. S3, I mentioned, is today's protocol. NFS, others are possible via gateways. It is managed via a web-based graphical user interface or API that comes with the box. All host access is done via Ethernet, up to 10 gigabit ports. The software running is HDST object storage, and we use erasure coding to protect your data. Software upgrades are rolling, so you don't have to bring down the machine and update it. It just happens on the fly. And there's component level diagnostics running on the box, and if you want, the box can call home. If you don't want it, it can be disabled. It depends on your security preference. I'll share some use cases, but since time is limited, not all of them. So everything that's native S3 today can use this box just off the truck. All you do is you put it in your premise, you connect power, you connect Ethernet, and you're ready to go. The typical application would be backup or a central repository for remote office or branch offices. There's a whole load of legacy applications that can run on the box, and there's big data analytics, and these two I'll address in a little more detail. So today, when we checked the catalog, we found that there's already 40,000 applications that speak S3 native available. So with those, you'll be ready to go out of the box. New cloud developments are focused on S3. When I left university, I had studied transistor formulas, and I had learned how to program assembler. People coming off university now in the IT field, they already know about S3. So everything that is created today talks to the box straight without any additional hardware. And if you're in big data analytics, most likely you're dealing with Hadoop today. There actually is an S3 connector supported by Apache. So while you couldn't process data on the archive, you perfectly well can move your raw data from Hadoop into the archive and back. And there are many organizations, I'll mention CERN as an example. They create about 60 petabytes of data on billions worth of equipment. And at the end of analysis, they focus on something else, but if they have an idea what they could have done with the data, they want these 60 petabytes back. Today, they're doing that with tape, and it takes them 18 months to get all the data to the tape. So my guess it would take them another 18 months to get data back. So this process actually gets in the way of progress. But with this kind of installation, we can actually guarantee access to individual objects in less than 100 milliseconds, which compares favorably to online archive solutions. If I take Google or Amazon, for instance, they would sell you an archive solution where you pay 3 cents per gigabyte per month, and you would get a 3-second response time, and you would have to pay for traffic on top. The solution I talked about here would sell for the equivalent of 18 cents a gigabyte once, so after 6 months you basically have recuperated your investment, if you utilize it fully, of course. And you would not have to pay for traffic because it's basically in-house. And just to sum it up once again, that's the box. Archive or shrink wrap storage, how a US colleague actually called it. It's utilizing a number of technologies that I want to highlight again. So our HelioSeal drive, this is a helium-filled drive, has lower friction, lower power consumption, lower noise, higher reliability. Bit spread, this is the erasure coding that we use on the drive to build enough resilience into the data that hard drive failures cannot lead to data loss. Bit dynamics, with that we constantly monitor the data for errors, we correct it proactively so we can get your data back after years of use. Geo-spread, if you need even more resilience and you have multiple installations across multiple data centers. And finally, the good news is this is SMR ready because today's recording technology, PMR, is at its limit. To stretch it further, we need new recording technologies that have very specific mechanical requirements because they're quite sensitive to vibration because of the high track density. So this rack is ready for that. The design is based on 30 years of experience in being in the OEM business as a component supplier, and we tried to avoid every mistake we came across in these 30 years by the design of this box. So I wouldn't say we're 100% successful, but we tried as hard as we could. And with that, I would like to end my speech, and thank you for staying behind. If I caught your interest with this machine, of course, you wouldn't spend close to $1 million just to try, so we actually offer proof of concepts. Today we can do that in the US. So we have machines standing in a co-location over there, and we can run it several ways. If you have an interest, speak to us. We can set up a time slot and give you remote connectivity just to try the protocol and other things relevant to you. If you actually are more interested in seeing real workload scenarios, you would actually have to hand over your data to us. You would have to hand over your application, and we'd run it in the co-location for you via remote control, so you would get a real-life impression of the capability of the machine. And now I'm happy to take any questions. If I left anything open for you, doesn't look like it. Then I thank you for your attention, and I gave you 10 minutes spare time. Thank you very much.